We continue our journey through the evolution of analytics. We started at descriptive analytics, what happened, moved on to diagnostic analytics, why it happened, and have now arrived at predictive analytics, what will happen. The transition from diagnostic to predictive analytics signifies a shift from expert-driven analysis, where the analyst must have a deep understanding of the business and how it works to drive insights, to data-driven analysis, where a predictive model finds patterns within the data to drive insights. You can begin by thinking of predictive models as formulas. These formulas quantifiably explain the relationship between explanatory variables and a predicted outcome. So how do analysts and data scientists determine the formula? To simplify the process, let's zoom back to elementary school, where you learn the abstracted formula for a linear functional graph, y equals ax plus b, where a and b are constants, x is the explanatory variable, and y is the predicted outcome. In predictive analytics, you start by gathering data for values of x and y. Using those, you can calculate a and b, and by doing so, you've built yourself a predictive model. Since a and b are constant, for any value of x, you will be able to calculate the predicted value of y. Now obviously, predictive models are rarely as simple as y equals ax plus b, and diving into the different kinds of models and techniques is a subject of a master's degree in the topic. The OG of predictive analytics is credit scores, a quantitative assessment of one's likelihood to repay a loan. Credit bureaus consider explanatory variables such as the amount you currently owe, your payment history, amount of new credit, length of credit history, etc., to calculate the predicted outcome, your credit score. Ever wonder why your FICO, Equifax, and Experian credit scores are all different? It's because all three credit bureaus use different predictive models. Here are three more examples where predictive analytics is used in marketing, retail, and fraud detection. Perhaps the most popular use case for predictive analytics in marketing is for upselling and cross-selling. This analysis is often called market basket analysis and identifies popular combinations of products. For example, many folks who buy flour and sugar also purchase eggs, most probably intending to bake a cake. Data scientists often will upload millions of customers' receipts through a market basket algorithm for such conclusions, and the marketers will action the results by optimizing physical or digital store layout, as well as offering targeted advertising. Retail businesses often leverage predictive analytics to help them forecast inventory demand. They look at historical trends and external factors to inform their locations how much of each SKU to stock. One local example is Texas Coffee Traders, who has experimented with using weather to predict demand levels for their cold brew coffee and adjust their inventory levels accordingly. My last example is using predictive models to proactively identify fraud. This is extremely common for e-commerce stores. There are actually third-party services that hold proprietary fraud detection predictive models and will monitor your e-commerce site and flag customers in real time who are undertaking typical behaviors seen correlated to using stolen credit cards and other fraudulent behavior. These customers engaging in suspicious behavior might be blocked from the site or assigned stricter security protocols such as reCAPTCHA when trying to check out. These are just three simple examples of how to leverage predictive analytics in business. The possibilities are endless no matter what industry, business, or use case you have.